Hello and welcome to Doug-Rivatives. So my topic was the product rule. The product rule is a formula used to find the derivatives of products of two or more functions. Now if this wordy definition leaves you a little confused looking, like Captain Jack Sparrow over here, don't worry, I got your back, Jack. Product rule is used when the functions f of x and g of x are differentiable. And so this formula will serve you well, both now and on the midterms, so I would recommend writing it down. The derivative of f of x times g of x is equal to f prime of x times g of x plus f of x times g prime of x. Now, if you'll remember, Mr. Lloyd taught us the mnemonic device low-de-high minus high-de-low for quotient rule. There isn't as good a one of those for product rule, but I thought maybe product plus. Product rule has a plus sign in it, so just remember PP. So example 1. We have f of x is equal to 6x to the 5th plus 4 times 4x to the 4th plus x. Pretty simple. So for this now, as per the formula we used earlier, we're going to need the derivatives of both of these to plug back into our original formula. So 6x to the 5th plus 4, the derivative of that would be 5 times 6, which is 30, and then subtract 1 up here, x to the 4th. Alright kids, what's a derivative of a constant? 0! You did it! Dora's proud of you. And then 4 times 4, 16, x cubed, and then there's an implied coefficient of 1 in front of this x. Just bring that down. So taking all this and plugging it back into our original formula, f prime of x is equal to 30x to the 4th times 4x to the 4th plus x plus 6x to the 5th plus 4 times 16x cubed plus 1. We can do a little bit of simplification here. We can pull an x out of these two right here, and we're left with f prime of x is equal to x times 30x to the 3rd times 4x cubed plus 1, and then plus, we don't really have anything to simplify over here, it's still 6x to the 5th plus 4 times 16x cubed plus 1. So I actually overheard an argument earlier today between Lil Wayne and Lord Voldemort. Lil Wayne was like, hey, I bet that you can still use the product rule when you have more than two variables. I bet that you can do it with trig functions as well. Lord Voldemort was like, no, I think that you're wrong. Lil Wayne was like, oh yeah? Well, you know who's stupid? You are, Lord Voldemort. And Lord Voldemort was like, oh yeah? Well, I can think of a million ways to kill you. But actually, Lil Wayne is right. Product rule can still be used when you are multiplying more than two variables, and assuming you know your trig derivatives, you can do trig functions too. So this example's a little bit longer, it's got a couple more steps. F of x is equal to cosine of x times sine of x times 3x to the 4th plus 1. And it's like calcception, just product rule within a product rule. All we're going to do is group these two as f of x, and then leave 3x to the 4th plus 1 as g of x. And we're going to do product rule of this part right here. F of x is equal to cosine of x times sine of x. And so, as per the formula, f prime of x is equal to the derivative of cosine of x is negative sine of x times sine of x plus cosine of x, the derivative of sine of x is cosine x, and brackets. And we're going to take all of this and plug it back into our original derivative. So, f prime of x is equal to what we had before, the bracket of negative sine of x times sine of x plus cosine of x times cosine of x. All that is multiplied by 3x to the 4th plus 1. And then we had cosine x times sine x originally. That bracket is multiplied by 12x to the 3rd. I don't think that I need to pull out Dora again. So yeah, this is just a pretty simple derivative. And remember, all you calcoholics, don't drink and derive. Alright, hope that you enjoyed the calculus and the bad jokes, and hope you learned something.